This video is for the Unit 8 Study Guide. So to begin, we are going to evaluate exponential functions. So number one, it asks us to find f of 4 if f of x is equal to 3 to the x. So remember that f of 4 looks very similar to f of x. The only difference is instead of it being an x, there's a 4, which tells us that our x must be equal to 4 for this problem. So what we're going to do is everywhere we see an x in our function, we're going to replace it with 4. So that means we're going to have f of 4 equals 3 to the 4th. Well, 3 to the 4th means 3 times 3 times 3 times 3. 3 times 3 gives us 9. 9 times 3 gives us 27. And 27 times 3 gives us 81. Which means that f of 4 equals 81. Number 2 says find f of 3 if f of x equals 5 times 2 to the x. So just like we did on the last one, we look and see f of x and we see f of 3, and we notice that the only difference between f of x and f of 3 is that x has been replaced with a 3. So that means that everywhere we see an x in our function f of x, we're going to replace it with a 3. So that means we're going to do f of 3 equals 5 times 2 to the 3rd. So using our order of operations and our PEMDAS, we would start with parentheses. But in the parentheses, the only thing I have is 2, so I can't do anything with that. So then I would deal with my exponents. So I would have 2 to the 3rd. The only thing that's being raised to the 3rd power is that 2. So that means I'm going to do 5, and then I'm going to multiply it by 2 times 2 times 2. So that deals with my exponent. Now I'm going to multiply or divide left to right, whichever one comes first. So in our problem, I see 5 times 2 times 2 times 2. So now I'm going to go back, and now I've got a set of parentheses I can actually do something with. So in those parentheses, I'm going to say 2 times 2 is 4. 4 times 2 is 8. So then I'm going to say 5 times 8 gives me 40, which means that f of 3 equals 40. Number 3 says the value of a computer is modeled by the function v of x equals 2,300 times 0.02 to the 1/4 x, where x is the number of years since 2008. By what approximate percent rate is the value of the card decreasing per year? So when I look at my function, I notice that it doesn't look like all of my other typical exponential functions. So typically an exponential function would look something like f of x equals ab to the x. And so the big important part about that is that I have my b being raised to the x power. But when I look at this function, I see that my b, 0.02, is being raised to the 1/4 x power. So these two don't exactly look quite the same. The problem is I need to deal with this 0.02 to the 1/4 before I can do anything else. So I would go to my calculator, and I would do 0.02 and I would raise it to the 1/4 power. So I'm going to hit the caret button and then alpha y equals and enter to get my fraction, and then I'm going to do 1/4. So then I have 0.376060393. Now we're not going to use that whole decimal, so let's round it to 2 places after the decimal. So if I'm going to round 2 places after the decimal, I need to look at the 3rd number. The third number is going to tell me what happens to the second number. So when I look at the third number, I see that it's 6. And if it's ever 5 or bigger, it's going to bump up the second number. So that means that my 7 is going to bump up to an 8. So now I can rewrite my f of x to be 2300 times, and I'm going to replace this 0.02 to the 1/4 with 0.38. So 0.38 to the x. Now ask me by what approximate percent rate is the value of the car decreasing per year. So remember that in our basic exponential functions, A stands for the starting value and B stands for or has to do with the rate. So what I'm going to do is identify what my B is. So B is 0.38. But remember that whenever we're dealing with exponentials, even though our exponential function has B written as a decimal, we always want to change it into a percentage. So to change it from a decimal to a percentage, we're going to take our decimal and bump it to the right 2 places. And when we do that, that gives us 38%. However, this still does not represent what my rate is. So I know that my rate is decreasing because it's less than 1. And anytime it's less than 1, that means it has to be decreasing. But I have to figure out by how much it's decreasing. So what I do is I start with 100%, and I'm going to subtract out 38%. So when I do 100 minus 38, borrow from that 10, make it a 9, so then I can have 10 minus 8, which gives me 2, and 9 minus 3, which gives me 6. So that gives me 62%. So the approximate percent rate, the value of the car is decreasing per year, is 62%. Number 4 says, a company opened 200 stores the first year. The number of stores has increased by 35% each year since the company began operations. Which function can be used to determine the number of stores operated by the company X years after it began? So because our problem has a percentage in it, that tells us that we're going to be dealing with an exponential. So we need to remember that an exponential is always going to look like f of x equals a times b to the x, where a is the starting value, b tells us about our rate, and x tells us about our time. So when we read back in the problem, we need to be looking for what we think is our starting value, what we think has to do with our rate, and what our time would be. So in the first sentence it says a company opened 200 stores the first year. That means that the starting value is going to be equal to 200. It also tells us that the number of stores has increased by 35% each year since the company began operations. So remember that we're not going to be able to just plug in 35%. Remember, if it tells us that it increased, that means that my value that's going to go in for B has to be bigger than 1 because it's being increased. So increase tells us it's going to have to be bigger than 1. So the rate that they give us is 35%. So what I'm going to do is take that 35% and I have to add 100% to it to get my percentage that it's actually being multiplied by. So when I do 35% plus 100%, that gives me 135%. But that is written as a percentage, not as a decimal. And remember, we can never plug in a percentage into our problem. So we need to change it into a decimal. So what we're going to do is take 135%, and technically it would look like 135.0%. Take our decimal and move it back 2 places. So whenever we do that, that gives us 1.35. So that is going to be what our B value is. So as I look through my answer choices, I can automatically eliminate B because I can notice that B is written as a linear function. We had already determined that it had to be exponential because of that percentage. I can also eliminate A because it tells us that the number of stores is increased, which means it's got to be bigger than 1. So my B value has to be bigger than 1. And so C matches everything we need it to be. So our function should look like f of x equals 200 because that's our A times 1.35 to the x because x represents our years after it began. Number 5 says Samantha buys a boat for $45,000. The value of the boat is given by V of t equals 45,000 times 1.06 to the t, where t is the number of years Samantha has owned the boat. Find the value of the boat 6 years after Samantha purchased it. So we have our function V of t, which is 45,000 times 1.06 to the t. We know that t is the number of years Samantha has owned the boat. And it tells us that we are worried specifically about 6 years. So for our problem, t is going to be equal to 6. Which means that we're going to go here and plug in 6 for t. So we'll have 45,000 times 1.06 to the 6th. Our calculator will easily work this problem out for us, so we'll say 45,000 times 1.06, do the caret button, to the 6th power. And when we do that, we get 63,833.36005. Remember, though, that we're talking about the value of a boat, which means that we're talking about money. So we need to make sure that we round our decimal 2 places. So our answer is going to be 63,833.36. Number 6 says a new car is purchased for $38,000. If V equals 38,000 times 0.85 to the x gives the car's value after x years, about how long will it take for the car to be worth half of its purchase price? So first of all, we want to know when the value of the car is going to be half of its purchase price. So if its purchase price was $38,000, we need to find half of $38,000. So half of 38,000 would be 19,000. So what we're looking for is when the value of the car is $19,000. So essentially, we're looking for this. We need to figure out which of these years in our answer choices will get closest to 19,000. So I would start with 3. So if we're going to start with 3, we're going to plug in this part into the calculator. But instead of doing x, we're going to replace it with 3. So it would look like 38,000 times 0.85 to the 3. So that gives us 23,336.75, which is not 19, or not close to 19. So we'll mark out 3. If it were me, I would probably go with 5 years next, because that will give me an idea of whether or not I need to go up or go down. So I'm going to start with, or I'm going to do 5 years now. So I'm going to replace this x with a 5. So I'm going to do 38,000 times 0.85 to the 5th. And so when I do that, it gives me 16,860.80, which means that it's depreciated too much. So that tells me that 5 is also not going to be it. So now let's try 4. That means that we can eliminate 6 as well, because that's going to depreciate even more than the 5 years did. So let's try 4 and just see what we get. So 38,000 times 0.85 to the 4th. So when we do that, we get 19,836.2375, but that 7's going to bump up the 3 to a 4, which gets us pretty close to 19,000. So B would be our answer. Number 7 says the function f of x equals 1.86 times 1.08 to the x models the value of an investment in thousands after x years. What is the yearly interest rate the investment is earning? So this question is asking us for the interest rate, which means that if we think back to how an exponential is written, f of x equals a times b to the x, the b would be our interest rate. So I'm going to look for what the b would be in the function that I'm given. So b is equal to 1.08. Now because b is bigger than 1, that tells me that the value is going to be increasing, which means I have an appreciation problem. And to figure out what the rate is going to be, I'm going to need to take this and turn it into a percentage. Because when they ask us about the rate, they're looking for a percent. So we're going to take the decimal and move it back 2 places to the right, which gives us 108%. But remember, anytime that we're dealing with b, we are always going to be doing something to be related to 100. So if b is bigger than 100, like 108 is, we're going to do 108 minus 100. When we do that, we get 8%. If by chance B had been less than 100, we would do 100 minus whatever the B is. For this problem, though, because we did 108 minus 100, we got 8%, which means that that's our interest rate. Number 8 says, write a function that represents the starting value of $2,000 that grows at a rate of 12% per year. Now, it asks us to write us a function, and because it is including 12%, that means that we're going to be writing an exponential function. So our exponential functions always look like f of x equals a times b to the x, where a equals the starting value, b is going to tell us about the rate, and x is always going to represent time. So in our problem, it tells us that it has a starting value of 2,000, which means that our a is going to be equal to 2,000. It also tells us that it grows at a rate of 12%. But remember, if it grows, that means that it's got to be something that's bigger than 100%. So if I think about 12% and it's growing, I'm going to add to that 12% 100%, which is going to give me 112%. But remember, I can never plug in a percentage in for b. b always has to be a decimal. So I'm going to take 112.0%, which means exactly the same thing as what we started with, and I'm going to take my decimal and move it back 2 places to the left, which is going to give me 1.12. So my rate that I'm going to use is 1.12. In the problem, it tells us that it grows at a rate of 12% per year, and they call the year t. So for my x, instead of it being x for this problem, it's actually going to be t. So now that I've got my a and my b, I can write my function. So my function is going to be f of t equals 2,000 times 1.12 to the t. Number 9 says Sandy's money market account earns 2% interest per year as long as she makes a deposit each year. Which type of function would model Sandy's account after t years? A linear function with positive slope. B, a linear function with negative slope. C, exponential growth function. Or D, exponential decay function. So to begin with, because in the problem it tells us that it earns 2% interest, the percent is going to tell us that it's got to be exponential. So automatically we can eliminate A and we can eliminate B. So we're down to either exponential growth or exponential decay. Exponential growth means that the value is going to increase. Exponential decay means that the value is going to decrease. So using the context clues in the problem, I have to decide, is my money going to be increasing or decreasing? So when I read it again, it says Sandy's money market account earns 2% interest per year. Earns. So the word earns is going to tell us that the money value is going to be increasing, which means that C is going to be my correct answer. So the type of function that would model Sandy's account after t years would be an exponential growth function. Exceeding values. Number 10 says, what is the smallest positive integer value of x such that the value of f of x equals 2 to the x plus 2 exceeds the value of g of x equals 12x plus 8? So what I'm going to do for this is I'm going to pick a value for x that I'm going to plug in for x in f of x and in g of x, and I'm going to try to see which number I would have to plug in to make f of x be bigger than g of x. So let's pick a number like 4. If we pick 4 and we see that f of x is already exceeding g of x, then we know we need to go down in our x value. If we see that it's not quite there, then we know we need to go up. So let's start with 4. So if we do 4, we'll do f of 4 equals 2 to the 4th plus 2. Well, 2 to the 4th means 2 times 2 times 2 times 2, and then add 2 at the end. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So I would have 16 plus 2, which is 18. So I need to check g of x and plug in 4 for the x and see if that gives me a value that is bigger than 18. So I'm going to do g of 4, which is equal to 12 times 4 plus 8. Well, 12 times 4 gives me 48, and 48 plus 8 is going to give you 56. So that means that f of 4 is not exceeding g of 4, so I can mark out 4. It's definitely not going to be 4. All right, so I know that it's probably a good bit off, so I need to pick something that's a little bit higher. So let's go with 7. So if we do 7, we're going to do f of 7 equals 2 to the 7th plus 2. 2 to the 7th means 2 times itself 7 times. So there's 2 times 2 times 2 times 2 times 2 times 2 times 2, and then I have to add 2 to the end. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 gives us 128. So we have 128 plus 2. $128 plus 2 will give us $130. So now we need to do g of 7. So when we do g of 7, we'll have 12 times 7 plus 8. Twelve times 7 is 84. 84 plus 8 gives us 92. So we can see that f of 7 is bigger than g of 7. So now we have to decide, was f of x bigger than g of x before 7? So let's try 6. So if we do 6, and we see that f of x is still bigger than g of x, then we know we need to go down again. So we'll do f of 6 equals 2 to the 6th plus 2. Well, 2 to the 6th means 2 times itself 6 times. And then add 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So 64 plus 2. Well, 64 plus 2 gives us 66. So let's try g of 6 and see if it's bigger or smaller than 66. So 12 times 6 plus 8. 12 times 6 is 72. And 72 plus 8 is 80. So f of 6 is not bigger than g of 6. So that means x has to be equal to 7. 11 says, what type of function is modeled below? So for each one of these situations or pictures, we're going to have to determine what type of function you may have. So remember that the three types of functions that we've talked about are linear, quadratic, and exponential. So on A, we can see that the graph has a slight curve to it. We can also see that it starts to kind of level out right at the x-axis. Because it has sort of a slight curve to it, we can automatically eliminate linear function. And because it doesn't wrap all the way around, we can eliminate a quadratic function. So this is an example of exponentials. And particularly, it's exponential decay because the value is getting smaller as time goes on. So this is exponential decay. On B, we can see this is a straight line. It is rising up to the right, which means that it's going to be a positive linear function. On C, we can see that it's a complete curve pattern, which means that it's going to be a quadratic. And because it's open up top, that means that it's a positive quadratic. On D and E, we're given a table, and we have to determine if it's a linear, a quadratic, or an exponential based on the table. So remember, when you're given a table, you're always going to look at your Y column, and you're going to see what's happening in your number values. So a linear is going to add or subtract. A quadratic is either going to increase, then decrease, or decrease, then increase. You also may notice some numbers start to repeat. And with an exponential, you'll either multiply or divide. So to begin on D, you're going to start with 8. And you're going to say, to get from 8 to 4, what did you have to do? So you could have either subtracted 4, or you could have divided by 2. So let's look at what happens from 4 to 2 and to determine what would have happened here. So to go from 4 to 2, you would have to divide by 2. So this is going to be divide by 2. This is divide by 2. And to get from 2 to 1, you would also divide by 2. So because we're dividing each time, that means that it's going to be an exponential. And particularly because we're dividing each time, it's going to be exponential decay. On E, we've got 16, 18, 20, 22. So to go from 16 to 18, you'd have to add 2. To go from 18 to 20, add 2. And to go from 20 to 22, you would add 2. So because you're adding each time, that means that you're going to have a linear. And particularly because you're adding, you would have a positive linear function, which means that if you were to graph it, it would look like this. F, G, and H give you specific situations, and you have to determine if it's linear, quadratic, or exponential. F says the cost to purchase different weights of apples at a produce stand. So for F, probably the easiest thing to do is to think about this in terms of something that you understand, which is how money actually works. So let's say that the cost per pound was 50 cents. So it's 50 cents for each pound. That means that 1 pound is 50 cents. 2 pounds is going to be $1. 3 pounds is going to be $1.50. So each time you were increasing by the same amount because you were increasing by 50 cents each time. So if we think back to what we were talking about when we talked about the tables, linear functions mean that you add or subtract. Quadratic functions are going to either increase and then decrease or decrease and then increase. And exponential functions are going to multiply or divide. So because I am adding 50 cents each time, this is going to be a linear function. G says the value of a house that increases its value by 8% per year. The 8% gives it away because anytime you see a percentage, it's going to be exponential. H says the total number of miles run by a person who runs 3 miles per day. So if we made a little table, and this was the day, and this was the miles, the first day, you would run 3 miles. The second day, you would run 3 more than the last day. The third day, you would run 3 more than the last day. The fourth, you would run 3 more than the last day. So each day, you were adding 3, which is going to make that a linear function. For the same reason, the F was a linear function, because you were adding or subtracting the same amount each day. "12 says identify whether each sequence is arithmetic, geometric, or neither. Remember that arithmetic means that you add or subtract, and geometric means that you multiply or divide. So if we start with 2, to get to 18, we would either add 16 or we would multiply by 9. To get from 18 to 162, you have to multiply by 9. And to get from 162 to 1,458, you would multiply by 9, which makes this a geometric sequence. In B, to get from 3 to 5, you would add 2. To get from 5 to 7, you would add 2. And to get from 7 to 10, you would add 3. So even though you were increasing by 2 on the first 2 numbers, because you increased by 3 on the second number, or the third to fourth number, this one is going to be neither. Because you have to add or subtract or multiply or divide by the same exact number every single time. So because there was not the same distance between 7 and 10 that there were between 3 and 5 and 7, then that means that this is neither an arithmetic or a geometric sequence. To get from 5 to 20, you would either add 15 or multiply by 4. So let's look from 20 to 80. To get from 20 to 80, you would either add 60 or multiply by 4. So that means that our pattern most likely is going to be multiply by 4. To get from 80 to 320, you would multiply by 4. So because we were multiplying by the same number every time, this is going to be a geometric sequence. "13 says find an explicit formula and find the sixth term of a geometric sequence 3, 6, 12. Because it tells me it's a geometric sequence, I know that a geometric sequence always has the form a times r to the n minus 1, where a is the starting value, r is my multiplier or divider, and I know it has to be one of the two because it's a geometric sequence, which means I'm either multiplying or dividing. And then n is going to be my term number. So in this particular problem, my sequence starts with 3, so my starting value is 3. To get from 3 to my next term, I had to do 3 times 2. And to get from 6 to my next term, I had to do 6 times 2, which means that I have a multiplier, and that multiplier would be 2. My term number, it tells me I'm looking for the 6th term. So when I write my formula, it's going to look like 3 times 2 to the 6 minus 1. That's going to be 3 times 2 to the 5th. So this is my explicit formula. To figure out what the 6th term would be, I would do 3 times 2 to the 5th, which means 3 times 2 times 2 times 2 times 2 times 2. I have to start with the stuff that's in parentheses. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So then I would do 32 times 3, which would give me 96. So my 6th term would be 96.